All right, this video is going to go to pages 5 through 8. So we're going to talk about impulse momentum theorem. So basically, impulse and momentum are the same thing. So we're going to kind of show you how we get there. So if momentum changes, then that means either the mass, if it helps if I turn my pen on, if a mass or velocity or both change. Okay, so that's how momentum happens. It needs mass and it needs a velocity. Okay, that's going to give you momentum. If momentum changes but mass stays the same, that means velocity was the one that had to change. Now, if velocity changes, that means an object is accelerating or accelerates. And if an object accelerates, that means there has to be a force acting on that object to make it accelerate. So the greater the force, the greater the velocity change, and in turn, the greater the momentum change. So that means if force goes up, your momentum, your velocity change is going to go up, therefore momentum goes up. So if force goes up, that means velocity goes up, and that's going to mean momentum goes up as well. But if a small force acts on an object over a long time, okay, you will also have a large momentum change as well. So that means if time goes up, okay, momentum goes up as well. So that means force and time both affect momentum. So increasing force and or time will increase your momentum change. So remember, impulse was J equals F times T. Okay, force times time. And since technically changing force and time can affect your momentum, that's why we can say, well, impulse equals change of momentum. So F times T equals M times V. Now, if you're dealing with multiple velocities, you can have F times T equals mass times VF minus VI. Okay, so all we're doing now is we're just taking the original equations we had, J equals F times T, and setting them equal to each other. So one thing you've got to really understand is this right here. Impulse and change of momentum are the same. So if I ask for momentum, and I don't give you mass and velocity, but I give you force and time, okay, then you can just do F times T. Or if I ask for impulse, and I give you mass and velocity, you can just do the equation for momentum. You've got to understand that both those can be used back and forth. So usually a good hint that you're going to use this equation is you're going to be given a lot of stuff. Okay, so like this problem, it says what velocity, so we're looking for velocity, will a 40-kilogram child sitting in a 40-kilogram wagon, so I'm dealing masses, acquire if pushed from rest, so that means your VI is 0, by a force of 75 newtons, there's your F, and for 2 seconds, there's your time. So there's a dead hint right there that you're going to use the big equation because you got a lot of stuff going on. Okay, so that means we are looking for VF. So we're going to do F times T equals mass times VF minus VI. So my force is 75 newtons. Time is 2 seconds equals mass. So the 40-kilogram child in the 40-kilogram wagon is going to be 80 kilograms. Your VF we don't know, and VI is 0, so VF minus 0. So all you're doing is just solving for VF. So your final velocity is going to come out to be 1.88 meters per second. And there's your answer for that one. Number 8, a car with a mass of 1,000 kilograms, so there's your mass, is traveling at 100 kilometers per hour. Okay, so can't have that velocity, so we got to fix that in the meters per second, so divide by 3.6, and that means you're going to get a velocity of 27.8 meters per second. Okay, so you got to make sure you fix that. When the driver sees a deer on the road, if the brakes can exert a force of average force of 5,000 newtons, how long will it take to stop? Okay, so that means VF is going to be 0 if we're coming to a stop. And then I have a brake force. Now, brake force acts against you, so you got to make sure you're paying attention to direction here. Okay, so brake force goes against you, so that's technically a negative 5,000 newtons for your force. And how long will it take? That means you're looking for time. Okay, so we're going to plug in, so negative 5,000. T times time, we don't know, we're going to leave it as T, equals my mass, which is 1,000. Okay, VF minus VI, so 0 minus your initial velocity of 27.8. If you're ever unsure about that, so remember F comes before I in the alphabet, so final minus initial. So that's going to come out to a time of 5.56 seconds. Okay, moving on to the next example. So I have a ball on a pool table, has a mass of 200 grams. Okay, so can't have that. So remember, divide by 1,000 if you want to fix that. So that's 0.200 kilograms, so there's your mass. Rolls towards a cushion at 2 meters per second, so there's a velocity. Okay, after hitting the cushion, it rebounds straight back at 2 meters per second. So this is my VI. Now it's coming backwards, so you got to really be careful with direction again. Okay, so you have a ball going in, it's going to hit the cushion, and it's going to come back at 2. So it comes in at 2, goes back at 2. But we're going to make that a -2 because they're going opposite directions. So I want to know, what is the change in momentum? So remember, change in momentum, P equals mass times VF minus VI. Okay, so we're just going to plug in. So mass is 0.200. Okay, VF is going to be a -2 minus your initial, which is 2. So be careful with this problem, because the number one mistake is people forget that sign and they just say, well, 2 minus 2 is 0, so therefore the whole thing's 0, and then they're just done. Okay, so -2 minus 2 is -4 times 0.2, and you should get a value of -0.8 kilograms times meters per second. So that's your answer for A. Now, B, it says how much impulse did the cushion give the ball? So remember, we talked about this is momentum equals impulse. Okay, so if you know momentum, you don't have to do more work. Okay, all you got to do is just basically take this answer right here and just bring it down here. Okay, so it's going to be J equals -0.8. And since we're talking about impulse, it's technically newtons times seconds. Okay, so that was your answer there. Number 2, a 10 kilogram mass is at rest. So here's your mass. Your VI is at 0. When it's acted upon by an unknown force for 1.5 seconds, there's your time. If the final velocity of the mass is 5 meters per second, there's VF. What is the size of the force? That means you're looking for F. Okay, so F we don't know. We're going to leave it as F. Okay, time is 1.5 equals mass, which is going to be 10, times VF minus VI. So we're just going to put 5 there because VI is 0. Okay, and we're going to get a force of negative, nope, not in this case, we're looking at the wrong problem, 33.33 newtons. Now, number 3, a girl with a mass of 80 kilograms jumps out of an airplane, so there's her mass, and after free falling for a little while, pulls the ripcord on her parachute. How much force? That means you're looking for F. Will the parachute have to exert in order to slow her from 100 kilometers per hour to 10 kilometers per hour? So there's your VI, there's your VF. We got to fix them. So divide by 3.6, you get 27.78. And on this one, you get 2.78. Okay, so those are your velocities in meters per second. And I gave you a time. Okay, so we're looking for force. Force we don't know. We're going to leave it as F. Your mass is going to be, time, which would be 10, equals mass, which is 80. VF minus VI, so 2.78 minus 27.78. Now solve for F, divide both sides by 10, and you should get a force of -200 newtons. And there's your answer for that one. Number 4, a diesel engine exerts a force of 100,000 newtons. Okay, so there's a force on a string of empty boxcars at rest, so VI is 0. Okay, and causes them to speed up to 2 meters per second, there's VF. And in 20 seconds, there's your time. If the boxcar has a mass of 2,000 kilograms, how many cars were there? Okay, so we have force, so 100,000 times time, which is 20, equals mass. We do have a mass here, but that's not technically what it's asking for. We're looking for how many boxcars are actually on the train. So we need to figure out what is the mass of the train, so we need to actually find M. VF minus VI, so 2 minus 0 is 2, which is going to give you a mass of 1 million kilograms. Okay, now we want to figure out how many boxcars there are, and each one weighs 2,000 kilograms, so divide this by 2,000, and you're going to get 500 cars as your answer. Okay, moving on to page 7. So what we're going to do is we're going to explain why it's not good to run into a brick wall. I feel like most of us should know why. Okay, but we have our mass. We have the same car. Both have a mass of 1,000 kilograms. Their initial velocity is 20 meters per second in both scenarios. Their final velocity will be 0 because they're both going to come to a stop. Okay, and then your time. Okay, down here you have time to stop, so it takes 3 seconds to stop when you hit the hay. It takes 0.25 seconds to when you hit the brick wall. So we're going to figure out mathematically why it's not a good idea to hit a brick wall. So we're going to find the change of momentum. So remember, change in P equals mass times VF minus VI. Okay, so we're going to plug in. So our mass was 1,000. Our VF is 0 because we're stopping, minus your initial velocity of 20. It's going to give you negative 20,000 kilograms times meters per second. So there's your answer for number 1. It says calculate the one for each car, but it's both the same scenario. They're both the same car. They're both coming to a stop. So I'm not going to do the same thing twice. That is your answer for both. Okay, number 2 says find the impulse. Well, remember, J equals momentum. Impulse equals change in momentum. So therefore, it's also negative 20,000 newtons times seconds. Okay, so you got to really make sure you understand how these can go back and forth, because what we can do is we can use that momentum to find a force or time, like in number 3. Now we want to do is we want to find the force on each car. So remember, J equals F times T. So negative 20,000 equals F, and my time to stop in the brick wall incident is 0.25 seconds. So divide that by 0.25 seconds, and you're going to get a force of negative 80,000 newtons. Okay, so now what we're going to do is we're going to compare that to the hay. So we're going to take that same impulse, so negative 20,000 equals force times time. Now my time is 3 seconds. Okay, so divide both sides by 3, and you're going to get a force of negative 6,667 newtons. And if newtons is force, okay, you can probably figure out which one you would rather feel, the 80,000 newtons or the 6,667 newtons. I'd rather feel the less one. So why is it better to hit the haystack than a brick wall? Is because if you increase the time, what you're going to do is you're going to decrease the force. If you increase the time to stop, the force has to be lower. Okay, so this is why, like things in football, that's why your helmets are designed to give instead of being rigid. If it was rigid like a brick wall, okay, then that basically means your head stops on a dime, which is very bad. Okay, or the reason why your car is designed to crumple. Okay, old cars like in the back in the 50s, 60s were just straight metal. So if you got into a wreck in those bad boys, they stopped pretty much instantly because they didn't crumple at all. So therefore, you're going to go a lot faster toward that steering wheel, which is going to be a little bit bad. Okay, but cars these days are actually designed to crumple. When they crumple, it's kind of like imitating this haystack right here. What it does is it increases the time to stop your car, which is going to decrease the force that the passengers are going to feel. So if you increase time, therefore you decrease force. Okay, and we're going to go on to the next one. So this one is just practice. This is a homework. This is just practice proving that, well, if force times time equals impulse, which is J, and I know that impulse and momentum are the same thing, then therefore I can set force times time equal to mass times velocity. So we're going to use this to figure out what are our missing pieces. Okay, so right here, if I know mass times velocity equals momentum, that would be negative 40 right here. Well, I know negative 40 equals impulse, so my momentum equals impulse, so this is going to be negative 40 as well. Now I know impulse equals force times time. Well, I'm just going to do J divided by T in this case, so negative 40 divided by 0.01 is going to give you a value of negative 4,000 newtons. Okay, next one, we're going to see what we have. Well, you can figure out, we can do impulse. We can do this first box right here. Okay, I know impulse equals force times time, so negative 40 divided by 0.1. That's going to give you negative 400 newtons. Now, I know impulse equals momentum, so that means J and P have to be the same. Now, negative 40 equals 10 times velocity, so negative 40 divided by 10 is going to give you a velocity of negative 4. Next problem is, you can take a look at what you got. Okay, I do have momentum, okay, and I've got mass right here, so negative 200 divided by 50 is going to give me negative 4 for my velocity. And I know momentum equals impulse, so I can put negative 200 equal right here. And then negative 200 divided by 0.01 is going to give me negative 20,000 newtons. Number 4, we're going to see what we have. I have momentum. Okay, so and then I have velocity, so I can take negative 200 divided by 8, okay, is going to be 25 for my kilograms, my mass. And I know negative 200 momentum is going to equal negative 200 on the impulse. So negative 200 divided by that 20,000 is going to give me a time of 0.01 seconds. And last one, I do have force and time right here, so I can multiply those to get my impulse. So negative 200 times 1 is going to give me negative 200. And I know impulse and momentum are the same, so this is negative 200 as well. And negative 200 divided by 50 is going to give me negative 4. And that will end that one.